Welcome back, my students. We are still in our geometry review before we really dig into Algebra 2. We're going to talk about perimeter, area, volume, surface area, and something we didn't talk about last year was sectors of circles. So perimeter, we know what perimeter is. If we have a shape, regardless of what that shape is, as long as it actually creates a shape, hello. Let me use my shape tool. That'll do better. There we go. We know that regardless of what the shape is, if we are given, let's make this a 9 because it looks more believable, 5 and 6 and 4. If we are given, or we can ascertain somehow the lengths of all the sides in a polygon, and a polygon is any shape with flat sides and corners, we can just add all of these up and get our perimeter. And the perimeter is just the distance around the outside edge of our shape. So in this shape we have 10, 9, and I like to mark out that I've written them down so I don't lose track. 6, 5, another 6, and a 4. So now I know I've gotten all of my measurements, and I just add them together. That's 19, that's 25, that's 30, and another 10, that's 40. So 40 would be my length or my perimeter around this shape. Now when we have a circle, we have to have a special way of finding that. And the way we do that is by using pi. We'll say that's the center, and let's say this is a radius of, oh, I don't know, we'll say 2, just for the sake of funsies. We know that the circumference of a circle is calculated at 2 times pi times the radius. We also know that 2 times the radius is the same thing as the diameter. So diameter pi is also an acceptable method for calculating circumference. In this case, the diameter, our radius is 2, so our diameter is going to be 2 times 2, so that's 4. So 4 pi would be the circumference of the circle. And this is the most exact way you'll ever express the circumference of a circle. However, mathematically, sometimes we need an actual number, like we're buying, I don't know, yards material to go around somebody's waist. So we have to put in a number here, and that number, when we round it down to 2 decimal places, it's going to be 3.14. And that's the number we use for calculations, and we get really, really close with that number. So that's why we use that. So that's going to be 12 point, and then this is going to be 56, I think, yeah, 56. So 12.56 of whatever units that is in length would be the circumference of a circle with a radius of 2. All right, so I hope you guys remember how to do that. Now we're going to talk about area. Okay, this was perimeter. Perimeter, you just add up all the lengths of the sides, and that's the distance around the edge. Circumference, you need a formula. Okay, and we'll go over this, we'll continually go over this because we're going to use it a lot. We always do. All right, so let's move on. Write that down if you need to. Pause the video as you need as we go through. Remember, in my class, if I'm going too fast, pause the video. Take the notes. You can even rewind the video if you don't understand the notes, just to try to clarify what I've written. And then press play and we'll continue with me. That's the beauty of video, is if you're in class, you just have to go at whatever speed I'm at. But if you're on video, then you get to pause me, rewind me, play me again, to get the instruction that you need, because we all learn at different rates. And sometimes, very rarely, but sometimes I might go too slow. I might ramble. Like right now, I'm rambling. So you could fast forward or set your speed at 1.5. Go a little bit faster and skip over all my rambles. Let's talk about area. It just depends on you and what you need to learn. All right, we know that the area of a rectangle, let me draw a little rectangle here. I'm thankful for this program that fixes my bad drawing skills. There we go. All right, so this is a rectangle, and we know that if this is 2 and this is 4, then we have 2 units tall, and we have approximately 4 units here. They're not great units, but they're units. So if we have 2 units tall and 4 units wide, we know that that's actually 8 units. 2 times 4 is 8, and we can prove that by counting the units, right? So we know that the area of a rectangle or any other shape that has 4 corners is going to be length times width, or a dimension of x times, what did I use? X times y. Whatever those two dimensions are, you could say height times depth. You could say width times height. 2 dimensions. It doesn't matter what you call them. You can name them Fred and Tom for all I care. What matters is that area equals the first dimension or measurement times the second dimension or measurement. Okay? And that's how we find the area of a shape. Sometimes it's going to be called base times height. Again, length times width, doesn't matter. Now, when we find the area of a circle, that's a little bit different. Let me get my shape tool to help me make a better circle. There we go. So if we have the area of a circle, we have to bring our old friend pi back. The area of a circle is a little bit different than the circumference in that we say pi r and we square it. So remember, with circumference, it's 2 pi r. With area, it's pi r squared. So you still have the same characters, they're just rearranged a little bit differently. So if our radius of the circle is 4, that means that our equation here is going to be, or our formula here, is going to say pi times 4, and 4 is going to be squared. Okay, 4 squared is 16, so 16 pi is going to be the area of the circle. That's the most exact way that we can describe it. But if we have to have an actual real number, let's say we're buying flooring for a circular room, we need to know how much flooring we need, right? So we'll take 16 and multiply it times 3.14, and that's going to come out to 50.24. So 50.24, and whenever we talk about area, whatever the dimension is, it's going to be squared, okay, because it is talking about a length and a width. With perimeter and circumference, it was just a length. It was one dimension. When you move on to area, you have those 2 dimensions. So let's say if this was in feet, this would be feet squared. And what that tells us is that it's this by this. It's not just a straight line. We're not buying a length of something, we're buying an area of something. That is what this indicates. So anybody who sees this measurement is going to know, oh, that's square feet. I need that in a flat covered space. Okay? That's that indicator. And the same thing here. If we have 8, let's say this was inches, they'd be squared. So you always have this little number here indicates. And the way we get there, think about your exponents for just a moment. If you have 2 inches times 4 inches, we can pretend that this unit of measure is actually a variable, and we can put a little exponent here. So when we take our 2 times 4, we get 8, but then we have our inches times our inches. That exponent increases. We add the exponents together because they're the same base. So it works for units of measure as well as variables. So if you think about it in those terms, it will help when we do unit conversions, and it will also help whenever you're doing your multiplication to find area and volume. All right, so let's move on to the triangle, the area of a triangle. I think I can do that right here. So if we have a triangle here, I'm going to make a right triangle just because right triangles are pretty easy to draw. Okay, we know it's a right triangle because we have the little square down here in the corner that tells us it's 90 degrees. That's pretty darn helpful. All right, so if our height is 3 and our base is 4, we can kind of look at this shape and compare it to this one, and we can see that the triangle is half, right? We can visualize that if this went over to this point, this went up from that point, and they crossed, that would form a square, or close to a square. It's 3 by 4, so it's not a perfect square, it is a rectangle. This line right here that creates a triangle cuts this shape directly in half. So that gives us our formula for the area of a triangle. The area of a triangle is quite simply the length. Actually, for triangles, they call it something special. They say it's the base, which would be 4, times the height, which would be 3, but then they divide it in half to get the area of this. And so base is 4 times 3 is the height. That's 12 divided by 2. The area of this triangle would be 6, and let's say it's inches. It'd be squared. Okay, because again, it's coverage of an area, not a length. And if you want to test that theory, let's say we cut this in half, and in half, and in half, right? And then we third this to get our 3 units. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units in total. But then we have 1, 2, 3, 4 solid units. This one and this one make 5. And this one make 6. So they're kind of cut just enough so that you can add them all up. You can kind of see that it's a total value of 6 full units. All right, but that is how we get the degree of measure of the area, or the measure of the area of a triangle, based on the height times half. Let's see what else we need to talk about. Oh yes, here we go. Let's do an example problem. If you don't already have these formulas in your let's say this one is area of a polygon, and we'll say it's length times width. There we go. All right, so if you don't already have those formulas in the back, written in the back cover of your notebook, go ahead and do so. You're going to need them all year long. All right, let's clear this and do an example problem. We have a nice odd shape for you here. And it kind of looks like it has a circle, and then it has a straight part here, and then it has a slanty part here. All right, and on the circle, let me move the center of that circle back. Here's the center of the circle. We're going to pretend that this is an actual half of a circle. The radius is 2, and then the flat part here is 4, and then the total length from here is our diameter. It's not very straight. Close enough. And our slant is 5. Okay, So we need to find the perimeter of the area of this figure. All right, so from here to here, and from here to here, and from here to here, we know. We have 4, 5, and 7. So we can add 4, 5, and 7. All right, that's cool. Now we need to find the half circle. We need to find the circumference for half of a circle with a radius of 2. All right, so the circumference is going to equal 2 pi r. And because it's a half circle, we're going to have to divide it by 2. So those two will cancel out. So pi times a radius of 2 is 2 pi. 2 times 3.14 is 6.28. So we add that in. And we get 6 and 4 is 10. 5 and 7 is 12. That's 22.28. And I think this is meters. And that's a length, so that's all we have to do. All right, remember those? Those were so fun last year. Let's do one more. Let's do example B12. All right, let me clear the page. All right, so for this, I'm going to draw us a little box. So we're going to do area. Okay. Now, within, let me change the color of this. I think I just have to do this right here. There we go. So within this box, we have a couple shapes that have been removed. Let's see, there's that. There's a circle. And then we have a right triangle. And those shapes have been removed from, I don't know why that didn't connect. Let me undo that. All right, let me try it again. Okay, there we go. All right, so within this blue shaded area, we have two shapes that have been cut out. We have a circle and a triangle that have been removed. Now, why would you want to use this? Let's say you're putting in some flooring and you want to use a different flooring here than you do here. Or maybe you have a wall that you need to go around. All right, or a built-in cabinet that you need to go around. So you need to take that out of your dimensions of length and width. It's always a possibility. Like this could be a, I don't know, a kitchen. And this could be the floor of the kitchen, the size of the whole room. But this could be the countertop island or the base of the countertop island in the middle of the kitchen. And this could be, I don't know, maybe you have a, some fancy, like maybe let's say you have a water fountain in your kitchen and that's the base of the water fountain. Or you have an herb garden in the middle of your kitchen. I know that would be really silly, but there you go. All right, so anyway, our dimensions for this, we have a center here and we have a radius of 4. This is 6, this is 5, this is a right triangle, okay? This is 15 and this is 10. So we need to find the area of just the blue part, not the red part. So the first thing we're going to do is find the total area, right? So 10 times 15, that's 150. We just move the 0 over. So that's 150, and this is in meters, so that's meters square. So now I got to subtract these two parts out of it. So we can find the triangle pretty quick. That's going to be, the area of a triangle is base times height divided by 2. So 6 times 5 divided by 2 is 30. So minus 30 meters square. For the triangle, that's going to leave us with 120 meters square. Now we got to take out the circle. So we got to do a little figuring for the circle. So the area of a circle, is pi r squared. All right, so r's is going to be 16 pi. And I think we already figured that once, but we'll do it again just for the sake of funsies. 16 times 3.14, 50.24. Yeah, that was the last thing we calculated. So 50.24 meters square is the area of the circle, so we subtract that. And I'm just going to do that on the calculator because I have one. I mean, what's the point if you are not going to use it, right? So minus 50.24, 69.76 is what we have. I don't know what that was. There we go. 69.76 meters square should be the answer that we get. What did I do wrong? I see what I did wrong. I subtracted 30 meters square here, and it's supposed to be half. Why did I not divide that by 2? I don't know. So let me redo this. This is supposed to be 15 because, see, when you hold stuff in your head, you make mistakes. It should be 6 times 5 divided by 2. I put 30. I didn't divide by 2. So you got to write stuff down. Even the best of us, if you write it down, you see what you're doing better, right? So that's going to be 135 meters squared minus 50, and that's going to give us 84.76. All right, that's the right answer. But see, I made a small mistake here and it threw all my calculations off. So it's always good to write down everything. So that was 15. I got that right because I wrote it down. I did this in my head and I didn't do the division by 2 and I got the wrong number. So write it down, walk it through, and you'll be closer to correct than if you try to put it all in your head and do it that way. All right, so moving on, I'm going to clear this page and we're going to talk about volume. All right, so with volume, we're talking about 3 dimensions. Instead of talking about a square, we are now talking about, or a flat shape, we're now talking about a shape that has depth to it. So it's got just a little bit more substance. So this has volume now. It's no longer just a flat piece of paper, it's a box. And so as a result, we have 3 dimensions. We have a height, we have a base, and then we have either a width or depth, depending on the angle that it's sitting at or who you're talking to. You know, either one works. And this base could also be called length. It doesn't matter. These are interchangeable. We don't care what you call them as long as you identify 1 dimension, 2 dimensions, 3 dimensions. Okay? That's the way that works. And again, volume is going to be the area. So we have our 2 dimensions here. We find our area first, and then area times height. That is volume. All right, pretty straightforward. So once you find your area, you just multiply it times your height, and then you will get your volume. So let's say we have that wonky shape again that we had earlier, the one with the circle and then a little slanty bit and it's straight across here. Okay, remember that? Here's our little diameter, and that radius that goes all the way out, by the way, is 2, and this was 4, and this was 5, and this was 7. All right, so now I have to find the area for this. So we're going to have to break it up into parts because we can't find the area for this wonky shape. So we can take a triangle off, pretty easy. We can take off a half circle. So we have three areas. We have area 1, area 2, and area 3, right? So area 1 is a half circle. Let's do it first. Area 1 is going to equal the area of a circle divided by 2 because it's a half of a circle. So it's going to be pi r squared divided by 2 because it's a half circle. The radius is 2, so that's going to be 2 times 2 is 4, and that's going to be 4 pi divided by 2, so it's going to be 2 pi, and pi is 3.14, so it's going to be 6.28. And the dimensions of this is in meters. So it's meters squared for the area 1. All right, area 2 is 4 across. And if we have a diameter here, or a radius, sorry, of 2, our diameter is going to be 4 also. So 4 by 4, that's pretty straightforward. That's going to be 16 meters square. All right, easy peasy. All right, area 3, let's put it here. We know this is a triangle, so it's base times height divided by 2. That's going to be, well, first of all, I've got to find our base. Okay, so if this is 4 and this is 7, then we could assume that this is 4 and this is 3, because 4 and 3 equals 7, right? So this is going to be a height of 3, I'm sorry, a height of 4, because this is 4 and this is 4, right? They correspond, and this is 3. It doesn't matter what this slant is here. This is the hypotenuse, by the way. This doesn't matter. It's extra information that you don't need. So 4 times 3 over 2, that's 12 divided by 2, that equals 6 meters square. So we can add all these three dimensions up. Area 1 was 6.28 meters square. Area 2 was 16, we'll do 0.00 just for the heck of it. And then area 3 was 6. All right, so 0.28, that's 8, carry the 1, so 28.28 meters square is the area of this shape. Now, this shape, let me see if I can draw this, is actually a three-dimensional figure. Ooh, not too shabby. Here's our radius of 2. And here's our little triangle. All right, and here's our diameter. We can visualize this shape on top of that a little bit better. So this actually has a height, and it has a height of, let's see, what does it say? We have a height of, it has a height of 3 meters. So all we have to do is take our area and multiply it times 3 meters. Okay, that's area times height. So our area times 3 meters, and I am going to use the calculator for that because I've learned in my lesson. 28.28 times 3 equals 84.84. So our answer is going to be 84.84 meters. And I want you to look at this variable, this meters, this unit of measure. We have meters squared and we have meters to the 1. So when we multiply variables or units with an exponent, we add them together. Remember that? So that's going to be meters cubed. And that is the correct answer. And it follows. We did what we were supposed to do. We got the area and then we multiplied it by the height. And that is how we solve for volume. All right. So we have some different cylinders. We have what we call a right solid, and that's what we usually measure when we do volume as a right solid. That means we have a 90-degree angle that we measure for the height. And a right solid could also be called a right cylinder. If the sides of the base are line segments, the base is a polygon, the cylinder can also be called a right prism. Okay, this would be a right prism or right cylinder because it has some curves to be right cylinder. If it were a cube, it'd be a right prism. If it were just a tube, it would be a right cylinder as well. When the bases are directly over one another, we know that the area or the volume, it can be measured. You know, we can see it exactly. And as long as the area on the top is the same as the area on the bottom, then we can use this formula to find our total volume. Now the volume of a cylinder equals the area of the base times the perpendicular distance between the bases, regardless of whether the cylinder is a right cylinder or not. So it doesn't have to be a right cylinder. If you have a cylinder that looks like this, all right, it's slanted. This is your top, this is your bottom. You find the height, and that's what you multiply by. It's not the length from here to here. Like this might be 10, this might be 6. It's the area of this circle times the height. So you find the height of the shape, not the length, okay? There is a difference when it comes to slanted. When they're not a right prism or they're not a right cylinder, there is a difference here, and you have to refer back to the height of the object, not the length of the object. So there is a distinction in what we call them and what those measurements are actually designated once we get past right prisms. Okay, the calculations are still the same. It's still going to be the area times the height, but we need to make sure it's height and not length. All right, I hope I've beaten that dead horse enough. When we get to cones, let's do cones next. I'm going to clear this page. Pause if you need to. When we get to cones, we know that cones have a different way to calculate. And a cone, the volume of a cone is, and I'm going to try to do this, it's a cone or a pyramid is base times height, and that is divided by 3. Okay? So with a triangle, the area of a triangle is base times height divided by 2. With a cone or a pyramid, it's base times height divided by 3. Gives us that measurement. So if you have a cone, I'll try to draw one here. Oh, that's not too shabby. You can almost see that little line in the back. You would find the area of the circle here. So whatever this area is, let's say that's a 2. And then you would have to find the height. And usually they give you a little line in here, and they say the height, let's say it's 5. So you'd find the area of the circle, multiply it by 5, and then divide all of that by 3. Okay? So let's try to do, oh, this is a really weird shape. We're going to find the volume of this kind of wonky cylinder here. Just a bunch of little curves, and it's slanted. I don't know if you can see. that three-dimensionally or not. I'm going to try to shade it just a little bit. So we got a little shading going on. I should probably draw this shape ahead of time. Yes, I went to art school. It doesn't really show. All right, anyway, you get the point. Here's the base. All right, so that's the same top and the same bottom. It is at a slant. Doesn't matter. We are given the area. We don't have to calculate it. Thank the Lord, because that would be a hard area to calculate. We are told that this is 242 meters square. And then we are told that this height here is 10 meters. So all we have to do is say 242 times 10, which basically means we drop a 0 on the end, and it becomes meters cubed, and that's our volume. Okay, and that one was super easy. That was example B3. All right, let's talk about this cone. So we have a wonky, like weird cone shape here. I'm trying to give it a little bit of shading so you can kind of see the three-dimensional aspect of it. All right, so there's our cone. It's like a double cone that's been added together, right? So we don't have to calculate it. We are told that the base is 242 meters squared. How about that? Same as the other one. And we're also told that the height of this cone is 10 meters. What a coinky-dink. Now, the difference is this is a cone and this was a vertical cylinder, right? This was a cylinder. This is a cone. So we have to say base times height divided by 3. So it's going to be 242 times 10, which we already know is 2420 meters cubed, but we have to divide that by 3. All right, so I'm going to use my calculator because I'm not going to do that in my head. 2420 divided by 3. Oh goodness, it's a big long number. So when you have a big long number like this is a repeating non-terminating decimal. Just round it to the second digit. So we're going to say 806.67. So this is going to equal 806.67 meters cubed. And that is how you get the volume of a cone. And this was example B4. And that's the reason why you have these different calculations, because the area was the same, the height was the same, but the overall shape was different. Oh, my dog is barking at something. I don't know what he's doing. All right, we have, oh goodness, we have some more stuff we have to go through. We have to go through surface area and then sectors of circles. I think sectors of circles is the main, yeah, that's the last bit that we have to go through. So we know surface area. Surface area is easy peasy. Let me go let him out and I'll do this. Hang on. All right, I'm back. Sorry about that. I had to let the dog out. So now we're talking about surface area. So let me clear this page for us. So in example B6, we have a right triangular prism. All right. And I'm going to draw kind of the interior here. There we go. All right, so you can see we have the slanted side, and we have a triangle here and a triangle here. We have a back and we have a base. Now this triangle and this triangle, they're congruent. So we can multiply whatever the area is here by 2. So we'll call that front and back. And that's going to be 2 times whatever our dimensions are here. So this is 4. This is a right angle here. This is 3. This slant is 5. And this length is 6. So this is 4 by 3. Okay. We know that a triangle is the base times the height divided by 2, right? So what we can do is we can go ahead and factor out multiplying by 2 and then dividing by 2, and then this just becomes base times height. So 4 times 3 equals 12. And the reason we can do that is because we have a triangle here, which is half of the rectangle, and a triangle here, which is the other half of the rectangle. So we have 6 and 6, which makes 12, because half of 12 is 6, and here's the congruent shape. 6 and 6 is 12, so we just eliminated in factoring, and to make that a simplified area or a simplified problem. You could do it the other way. You could go through all the steps. It'd still end up being 12. So now we have this side right here. I'm going to indicate it, and this side right there. Those are taken care of. Now we need the back. Okay, this is congruent to this, so we know that it's 6 long and 4 tall. So the back is going to be 4 by 6, and that's going to be 24. I'm just going to write them together here so I don't have to move them later. Now that's going to be, that back side is taken care of. Right? Now let's do the base. The base is 3 by 6. This little section here on the bottom. So we have 3 by 6 base, and that's going to be 18. And the only thing we have left is the sloped side, and that's this little section here. Let me make a different color. So it's this side here, this little slanted area. And we can see we have a dimension of 5 on this side, and we have a dimension of 6 over here. So that's going to be 5 times 6, which is 30. So now all we have to do, oh, Roscoe, hush. It's my dog. He's fussing about something. Now all we have to do is add all 4 of these sides up. And we get 10, 14, carry 1. That's going to be 4, 5, 8. So we get 84, and our unit of measure is centimeters. So it's 84 centimeters, and it's squared because we did surface area. We did not do volume, okay? We did the front and the back. We did the back, we did the base, and we did this slope side. And those it's actually 5 areas, comes out to 84 centimeters, but it's squared, okay? Surface area is, again, the external area of a 3-dimensional shape. We have another surface area problem. I think you guys probably get them by now, but I'm going to go ahead and do it because it's in the book. We have a cylinder here. Not the best drawing in the world. Let me see if I can get a little bit better. There we go. It's a little bit better. All right, I'll give you a little shading there. You can kind of see. All right, this is our cylinder. Here's the center. Here's a radius. The radius is 4. The height of the cylinder is 10. Okay. All right, so all we have to do is find the area of the circle, and that we have a top and we have a bottom. Okay, so top and bottom is going to be the area of a circle. And the area of a circle is pi r squared. So it's going to be 4 is the radius. So 4 times 4 is 16. So that's 16 pi. And we know, I think we've done this one before, 16 times 3.14 is 50.24. So we have, that's going to equal 50.24. And we're going to multiply that times 2 because we have a top and we have a base. So we are going to say 100.48. And this is in meters, so that's meters squared. All right, and that's the top and the base. Now we need to do the lateral surface area. And what we're going to do is we're going to draw a little line here. All right. And we're going to envision that this is a label. And we're going to peel it off. And when we peel it off, we get a rectangle. Right? Because this was around the top. This was around like on a can or paint can or a soup can. This was around the top. If you ever peeled off a label, you know it's a rectangle. So the height we know is 10, because that's what that says. This length here, to get our other dimension of area, this is going to be the circumference of our circle. Can you see that? So this is the circumference of the circle. So we're just going to do the circumference of a circle with a radius of 4 to figure out what this length or this circumference is, so we can put it on our label here, our rectangle we pulled off. So the circumference of the circle is 2 pi r. Okay. Well, r is 4. 2 times 4, that's 8 pi. 8 pi is 8 times 3.14. 8 times 3.14 is 25.12. And that's going to be the circumference here. And if we multiply that by 10, that's 251.2 meters squared. We're going to add that to this top and bottom. So 100.48 meters squared. Bring down the 8, bring down the 6, that's 1, that's 5. So 351.68 meters squared is the surface area of this cylinder. Okay? All right. So let's clear this page, pause if you need to, and then begin again. Now we're going to talk about the surface area of this really weird shape here. All right, this is B8. We have this shape here, but then it has a half of a circle on it. And in this half circle, there's a radius of 3. This is a 6, and this is a 5. And then we have this shape here. Let's try to make it look a little three-dimensional. Alrighty. There we go. Somewhat three-dimensional. So the height here is 10. Again, everything is 10. I don't know what this is. But our dimensions here are feet. I'm going to write that to the side just so we know. So we have the base of a right cylinder 10 feet high is shown. The surface area of the solid. Find the surface area of the solid. The dimensions are in feet. So we are going to just find the surface area. So we're going to find the surface area. We have to find the area here. And remember, we have an area on the bottom too. So we have a top and we have a bottom. Now, in order to find the top and the bottom, it's going to be 2 times whatever the area of this shape is. So let's find the area of the shape. All right, we just made that a rectangle or a polygon. Technically, it's a quadrilateral because it's 4 sides. Actually, it's not a quadrilateral. I'm sorry. It's a parallelogram. Quadrilateral has 4 sides the same. These two are not the same. So this parallelogram, which is a rectangle, is an area of 6 by 5. Okay, so that's area 1. Area 1 is 6 times 5. That equals 30 feet squared. Now we have a half circle. That's area 2. Area 2, we know the area of a circle is pi r squared. It's a half circle, so we're going to divide it by 2. R is 3. 3 times 3 is 9. 9 pi over 2. What is 9 times pi? 9 times 3.14 is 28.26. It's a half circle, so we divide it by 2. It's going to be 14 by 13. So that's 14.13. That looks like a B, not a 13. So 14.13 feet squared. And we're going to add those together. It's going to be 44.13 feet square. All right, that's the area. So now we put that in here. So 2 times that is going to give us 88.26 feet squared for the top and the bottom. So now we need to do the same thing we did before, and we just need to find the perimeter. We'll pretend that at this corner we're peeling off a label. We're going to find the perimeter of this whole thing and multiply it by 10. Okay, so our perimeter, that's going to be 10 times whatever the perimeter is. And that's going to be our lateral surface area. A lateral means sides, so it's going to be the surface area of our sides. Excuse me. Our height is 10, so it's going to be 10 times whatever this perimeter is. Well, we know what this is. Okay, we have 5 and 6 and 5, so we can add that together. So the perimeter is 5 plus 5 plus 6. That equals 16. Now our circumference, we have a half circle. Circumference is 2 pi r. It's a half circle. We divide it by 2. So those two cancel out. So we need pi times r. So it's going to be 3 times 3.14. And that's going to equal 9.52. Okay, so we're going to add those two together. And that is going to be 25.52 feet. And that's a length. So we are going to say, and this is 10 foot. And this is 25.52 feet. Okay, and this is a length and this is a length. Okay, this is length and this is height. Or perimeter and height, those are both just singles, so that's 1 and 1, right? So when we multiply that, we'll get the feet squared. So 10 times this is just moving the decimal place over 1. Now we can add them together. And we end up with not the right answer. All right, let me check my math. All right, I I get 3 times 3.14, 9.42. That's what I did wrong. It should be a 4 right here, not a 5. So that makes this a 4. Okay, so that makes this a 4, and that makes this a 2. All right, now that's the right answer. All right, so that's what I get for trying to do it in my head. Again, if you don't learn anything else, or if you don't remember anything else, remember, don't do it all in your head. You know, be smarter, and then you'll get it more accurate if you trust, you know, the computer and trust your paper. So let's change this to 254, and then this would be 342. All right, so 342.46 is the right answer for the surface area. And you can see how I did that. I did top and bottom. 2 times whatever the top was gives us the top and the bottom. And the lateral sides is just the height times whatever the perimeter of this shape is. In order to find the perimeter, we had to get the flat sides added together, and then we had to find the circumference for this half circle. Okay, and that's where I flubbed it up because I tried to do the math in my head. All right, that is, I believe, yes, it's everything I have on surface area for these typical shapes. Now we're going to talk about the surface area of the sphere. So I'm going to clear this. And this is something we haven't done before. Or if we did it at the very end of the year. Surface area of a sphere. There's an easy way to remember how to find the surface area of a sphere. The surface area equals the combined areas of 4 circles. Okay, each of which has a radius the same length as the radius of the sphere. So picture a sphere, right? And it has a center, like picture a ball. It has a center, and there's a distance from the center to the edge. That's your radius, okay? The surface area of the sphere, if you picture you have a diameter this way in the sphere, okay? That's from side to side. And then you have another straight across. That's the 2 diameters making perpendicular lines. Okay. Well, now that's a cross and a cross. Well, now you have one up and down too. You have one going this way, up and down, and then you have another one going this way, up and down. So it's 1, 2, 3, 4. So 1, 2, 3, 4 diameters. So 4 dimensions, or 4 cross sections of a sphere. So the way we find the surface area of a sphere, you know, a circle is flat, it's 2-dimensional, but a sphere has that 3rd dimension, so we have to capture that a certain way. And the way we do that is we say 4 pi r squared. That's how you find the surface area of a sphere. That's how you would calculate that. And there are formulas for lateral surfaces the lateral surface areas of many types of cones, and they are all different. The lateral surface area of a right circular cone. So if you have a right circular cone, then that surface area equals pi rs, okay? And s is the slant of the cone. That's called the slant height. That's the specific name for S. The lateral surface of a pyramid is the sum of the areas of the faces of the pyramid plus the base. Okay, so surface area of a pyramid you're going to do the area of the triangle for each side, and then you're going to add the base. So those are some things that you're going to want to know. So you are going to want to add this to your back cover. You're going to write add this to the back cover. All right. So now we're going to talk about sectors of circles. For these, all you have to do is plug in and follow the instructions. So it should be fairly clear. So let's clear this page. Pause if you need to. But we're moving on to section BE, which is sectors of circles. This is not something we covered in Algebra 1. If you had geometry last year, you might have covered it. A part of a circle is called an arc. So if you have a circle and that outside edge here of the circle, you just have a part of it, that's an arc. Okay, so the sector of a circle is the part that forms when you have a radius from one edge of the arc to the other edge of the arc. Let me see if I can, yes, I can connect that there. All right, so now you can see this is the sector. All right, and the angle here that is measured is also going to be the sector measurement, 27 degrees of the circle. That is the sector. We note that the degree measure of the arc is the same as the degree measure of the central angle formed by the two radius. There are 360 degrees in a circle. 1 degree of arc is 1 over 360 of a circle. So 27 degrees in this sector of the arc is going to be 27 over 360 of a circle. And the length of the 27 degree arc is going to be 27 of 360 of the circumference of the circle. So what you're going to do is you're going to find the radius of the circle, and then you are going to multiply it times this fraction of the circle in order to find out the area of the sector. Okay, so in this situation we have a radius of 6 meters. So we're going to find the area of the circle that has 6 meters. All right, the area of the circle. We know the area of the circle is pi r squared. So it's going to be 6 times 6, so that's 36 times pi, which is 3.14. Okay, and that is going to be 113 meters squared. And that's for the entire circle. Okay. Now the length of that, or the circumference of the circle, is going to be 2 pi r. So 6 is the radius, 2 times 6 is 12, 12 times 3.14. That is going to be, let me put my equal sign, that is 37.7 meters. So the circumference of the entire circle is this, the area of the entire circle is this. Now we're going to figure out just what the sector is, right? So to find the area of this 27 degree sector, we're going to multiply this times 27 over 360, because that is the percentage of the circle area that we have available to us. So that is going to end up, when we do the math, we put this over 1, we multiply this times this, we multiply this times this. Let's go ahead and do that for us. So we have 113 times 27, okay, and that's 1 times 360 is 60, so that's going to be divided, that's going to be 3051 divided by 360. So that's going to be 8.475. So 8.475, you could round that up to 8.48 meters squared. Usually we stop at 2 decimal places, so that's why I'm rewriting it like that. But this is the area of this sector, okay? We took this percentage, multiplied it times the total, and then this is the final result. So this is the area here. So we're going to do the same thing to find the length of this arc. We're going to say 37.7 meters times the percentage, the fraction that represents the percentage of the circumference. Put that over 1. And we are going to find that 37.7 times 27 is 1017.9 over 360. And that is going to divide to, let's round that up and say 2.83. Okay, so 2.83 meters, and that's a length, so there is no square. It's just from here to here. So that's how you find the measure of the length of an arc. You have to know the degree of the angle, and then that's how you find the area of a sector of a circle. You have to know the radius, and you have to know the degree of the angle. All right. So this is something that you are going to want to put in your notes. Set this whole entire example so you can see how to work a problem that has a sector of circles. Okay? Put all this in your notes. Pause, write it down, take your time. We're going to do one last example problem, and it's going to be a sector problem. So pause if you need to. I'm clearing the page. All right, so for example B9, this is our last problem. Let's draw our circle. Hopefully that, yeah, there we go. Looks close enough to a circle to me. Here's our center. And here is one radius. Okay. And we're going to make another radius here. All right, and if we had done this, this would be about halfway. So that makes this 45 degrees, which makes from here to here 45 degrees. And this radius is 10 centimeters in length. So the first thing we have to do is find the area of the circle, and that's going to be, in case y'all are wondering, that's supposed to be a radius to the center of a circle. That's why I do that. So the area of a circle we know is pi r squared. The radius is 10, so 10 times 10 is 100. 100 times 3.14 is going to be 314. And that's going to be centimeters. And because it's area, it's going to be squared. Okay. The circumference of the circle is 2 pi r. Radius is 10. 2 times 10 is 20. Let's use the calculator. Learning my lesson. 20 times 3.14 is 62.8. and that's a length, so it's just centimeters. All right, so now we have to find the area of the sector and the circumference of the arc, the length of the arc. So we're going to take 314. We're going to take, I read the wrong symbol here. We're going to take this area and we're going to multiply it times our representation of that portion of the circles. We're going to do 45 over 360 because it's 45 degrees out of 360 degrees. Put this over 1, and then we'll do the calculation here. We can do this all on the calculator. So we have 314 times 45 divided by 360. That's going to equal 39.25. 39.25 centimeters, and that's area, so squared. So the area of this sector of the circle is 39.25 centimeters squared. So let's find the circumference, the arc length here by this 45 degree. So we're going to multiply that times 45 over 360. We're going to do it all on the calculator because that's what we have calculators for. Clear this out. So we have 62.8 times 45 divided by 360. So 7.85. 7.85 centimeters is the length of this arc. Okay, so that was pretty straightforward. When you know how to do this, you just need the degree measure to find the percentage of a 360 degree circle. You find the total area, the total circumference, you use that percentage indicator, multiply and divide by 360, and then that gives you your answer. And those are the correct answers according to the book. So very good. That's all we have for the geometry review, lesson B. And we will start with lesson 1 next. So I'll see you in lesson 1.